Welcome to another CAE Defense and Security podcast. On this platform, we connect with our listeners to share inspirational stories, discuss new technologies, and exchange thoughts on a range of topics relevant to the global defense market. Check us out at cae.com/defense-security/ or subscribe on your podcasting platform of choice.
Good morning and good afternoon, everybody. This is Joe Armstrong, the Vice President of Global Operations, Products, and Solutions for the Defense and Security Business Unit. I'm really happy today because we're bringing technical fellows, people who have absolutely mastery of the technical capability of this company together to have an open conversation about what's new, what's innovative, and what the future looks like for CAE. I'd like to introduce everybody. I'll start off with Phil Perry, the Head of Technology for Defense and Security. We have Nick Giannis, the Senior Technical Fellow in Advanced Technology and Innovation. We have Jay Freeman, the Synthetic Environment Technical Authority. And we have Eric Simon, the Head of Innovation for Presages. So fantastic set of panel members, and I think everybody's going to be very interested in what we have to discuss today. With that, I'm going to pass the conversation immediately over to Phil Perry for him to start the discussions. Over to you, Phil.
Hey, great. Thanks, Joe. Really excited to have an opportunity to discuss the incredible amount of innovation that's underway within defense and security. And really all this started in 2018 as we looked at a $1 billion initiative called Project Digital Intelligence, where we're focusing on strengthening CAE's position as a world leader in training. This includes VR and AR capabilities, providing us a suite of new training capabilities, data analytics, cloud computing, and direct application of artificial intelligence and machine learning to improve the efficiency in training delivery, and also creating a much more immersive training environment. And all these capabilities are helping to grow the DNS business and training, but also positioning us in a new market called mission and operational support. So let's take a look at some of these recent achievements. CAE launched the Medallion MR-E series 24 months ago, almost to the day. And probably the most immersive training environment we've ever developed. It's specifically targeted to fast jet training market. It delivers some truly unique capabilities with dynamic distortion correction, so objects are always at the right place based on your head position, 120 hertz, so doubling the default standard in the industry, high resolution, as well as optional 3D capability, which really gives an incredible depth to the scene. We successfully sold 15 of these systems to BAE Systems for the next generation Typhoon Eurofighter trainers. Whole crew training is really a growing need, and CAE has developed a complete training solution for rear crews. This permits team training on gunnery stations, on winching, on confined area landings, and this unique mixed reality capability means that the students can look out any opening in the fuselage, but also interact with their fellow teammates. It was delivered on the Merlin Life Sustainment Program. That program is currently in its final phases, and we're now working on the second generation device for 2 NH90 programs that are currently underway. Following a detailed market assessment, we developed an entirely new self-paced training ecosystem that we launched last year called CAE Tracks Academy. And this is broken down into 3 segments: the learn, the practice, and the perform. And includes a new class of training device we call immersive training devices that we've branded CAE Sprint. So it uses a eye-limiting acuity helmet. It's got force feedback sticks. It has a true-to-life flight and avionics interface, and all in a backbone of data analytics. So we can use RISE and further data analytics so that we can monitor the students' progress as well as the entire cohort's progress through the training curriculum. As we look to further optimizing training delivery, we've also called upon artificial intelligence to help us. CAE was recently awarded a contract with the U.S. Air Force called the Defense Innovation Unit Pilot Training Transformation to deliver a revolutionary adaptive training environment. We are working with the Digital Accelerator as well as CAE USA in Tampa and Little Rock to deliver this capability in 2021. This is also being integrated as part of our developments for the CAE Tracks Academy in 2021. As we look beyond training, we recognize the knowledge and expertise we have in synthetic environments and how it can help us with mission and operational support. To talk more about this capability, I'll hand it over to Nick Giannis, who will talk to us about the innovations in SE. Nick?
Thanks, Phil. So for the last year and a half or so, I've had the pleasure of being involved in the Single Synthetic Environment Project in the UK, in the United Kingdom. It's a project led by the Ministry of Defence, working in partnership with innovative companies, and CAE is part of that, along with a startup company called Improbable in the UK. So what I'd like to do is take you through the vision for the Single Synthetic Environment. We're currently in phase 2 of the development of this vision. All right, so the Single Synthetic Environment will streamline, accelerate, and optimize planning, make collective multi-domain training more frequent, realistic, and effective, and transform operational decision support across organizations. It will offer faster than real-time analysis of simulated plans and large-scale wargaming, all enhanced by live data streaming from the real world. It will offer the opportunity for optimized plans to be trained against by thousands of personnel in highly realistic synthetic training and mission rehearsal environments. It will leverage the latest AI techniques to exploit the vast volumes of data produced, improving strategy and tactics simultaneously in a single, fully integrated, scalable product. The SSC will accommodate different platforms and forces and a variety of systems and geographies across multiple domains simultaneously. Hosted on a secure cloud infrastructure and accessible wherever and whenever it's needed, it will take into account the evolving strategic landscape and allow users to explore the latest technological advances before committing and procuring, as well as improving operational outcomes. The Single Synthetic Environment will reduce costs in both the short and long term. While it won't replace the need for real-world flying, sailing, or driving, it will reduce our reliance on live training, saving money, while also delivering a more complex, more challenging environment. So clearly, this is a compelling vision that was sponsored by the UK MOD, and in fact, we're seeing come up in various areas around the world. CAE is part of that in the UK and is starting to look in other countries as well to deploy this kind of capability. Our expertise in the defense and security market was key to us being part of the Single Synthetic Environment in the UK, but at the same time, we're expanding our capability in different areas, including the use of standards to do things like command and staff training and enhancing our existing products. So with that, I'll hand you over to Jay, who'll talk to us about using synthetic environments in areas other than training.
Hi, I'm Jay Freeman from CAE USA. I am the Synthetic Environment Technical Authority, and I represent both CAE USA and CAE MSI, which a lot of people probably don't know about. MSI works under a proxy with CAE USA to do mission support. So what's happening in the US DoD? So the need for data is expanding across the DoD. Why? Because there's a return to near-peer competition. So we say near-peer competition, what that means is conflict with someone like Russia or China, that if we're going to have this type of near-peer conflict, we need data in all the different domains. So we need a joint all-domain environment. So when you start to pull together all these different domains of data from cyber to infrastructure to space, what you quickly find is you need automation to distill that data to get timely information from that massive amount of data. And as technology expands, what we really find as a second derivative to this is the capabilities have to live at the edge, that people need these capabilities in their tactical devices because we're becoming accustomed to always being connected to the world, not only from our personal lives, but also at a warfighter level. So what does this really get to? We have to evolve our synthetic environments. We have to go forward. So one of the efforts that we have is what we call CDB 2.0, CDBX, as it's also known, which is an effort through U.S. SOCOM that's being picked up by the OGC through the CDB Standards Working Group. That's really trying to expand the core concept of what we know about CDB. So we're trying to expand it to concepts of being space and space warfare. So what does that mean to actually have a terrestrial and space-based simulation work together from a synthetic environment point of view? Cyber, right? So we all know that in the current world, there's lots of cyber threats out there. So how do you model some of these infrastructures and the vulnerabilities to cyber? And then, of course, human geography, the pattern of life. How do you understand where people are going to be at certain times, their habits, their hobbies? And when you start to build out this concept of synthetic environment, what you get to is, how do you support different things like mission command, or how do you support AI? And ultimately, that means, how do you structure data differently? Instead of being a layer-based approach, how do you do some object-based approach, especially when you want to get into mission command? So another initiative that we have in the US that you've heard talked about at a number of different meetings is something called US SOCOM Global Situational Awareness. But what GSA is really going to get is take our synthetic environments and exploit them in an operational environment. So we're going to connect to operational C2 systems where we can pull in the red forces, the blue forces, and start to use AI to do predictive analytics of what might happen. And ultimately take that overall common operating picture and push it to tactical devices. So in the US military, they have something that they called ATAC, the Android Tactical Assault Kit. So everyone wants to connect from command center to that tactical assault kit across those capabilities. And at the end, what we develop out of this is a 3D native common operating picture. So that's a pretty new concept for mission command, because historically these things have always been 2D flat data sets. Another effort we're doing with NGA. So FG3D, Foundation GeoInt in 3D, is a really, really exciting piece, because NGA, who's the primary data provider for the US and a lot of our coalition partners, has adopted CDB as their 3D data standard. So we've created a number of capabilities that exist all the way from top secret networks down to unclassified networks for users to log into that world of CDB content and pull out data to exploit it in their individual systems. So we've done a number of efforts to take satellite data and automatically create 3D content from that. Same thing with full motion video to 3D. How do you take these meshes and these point clouds and tear them apart to have models versus roads versus trees so that you can truly use and exploit these? One of the final things I'll talk about is federated co-production, which is another effort through US SOCOM. And this one's another pretty exciting piece where we're taking technology to that point of need in these new use cases. So how do we truly have web-based content creation from a crowdsourcing perspective? So everyone from operational units to contractors can go off and build and collaborate on this synthetic environment. And it's a really exciting time, because what this really gets towards is moving everything to be cloud native capabilities across the board. So you can live in that data on the cloud. And then there's a number of other things going on between ABMS, which is the Advanced Battle Management System, which is the Air Force effort to create a joint all-domain environment, to U.S. Marine Corps wargaming, where the U.S. Marine Corps wants to use CDB as their underlying synthetic environment to create new doctrine and validate their doctrine through war games. And then lastly, we're doing a lot of R&D pieces to try to stimulate more contract efforts and initiatives within the U.S. So at the end of the day, the U.S. DoD market is expanding these synthetic environments with new data types, automated 3D reconstruction from full motion video and satellite data. We're expanding the total use cases, and really we're expanding the accessibility of synthetic environments at the point of need. So with that, I'll turn it over to Eric Simone from Persatus, and he'll talk to you about velocity.
Thank you, Jay. So hello to everyone. So I'm excited to talk about velocity, and then what we're currently developing at Prestigious. So maybe some of you have heard about velocity already or not. So it started about 2 years ago, and then recently we had an investment book to actually turbocharge velocity. And velocity now is part of the growth initiative of CAE. So basically, why velocity? So we started to see that enormous amount of data digital data being available, geospatial data, and then cities, environment, everything start to have some ways a digital chip in it that provides some information, even small appliance and small systems. And then there is an explosion of information. And then now the question was, how do we harness that information? And to make it through simulation, actually, how could we use all those information to make useful simulation and then discover or do what-if type scenarios about it? So our challenge is about the enormous amount of data. So every day there is so much data generated now around the world that there is more data than we're capable to process. So we started to look at velocity being a way to automate that rich data component, how to automate that consumption and then make it logical, make it standardized and reliable, so we could use that for simulation on an almost real-time fashion. And then at the same time, we started to see from the geospatial data, and the M&S industry, so from those two industries, we start to see a convergence. GIS data that is mostly used in analytical principle. The GIS data is mainly 2D type data, and then there is so much of it now with the satellites and then all those geopositioning systems, and available from mobility, from cars, from even people working around with a cell phone. We could still capture data that is geo-reference. So the GIS industry start to consume all those data for analysis, and then going beyond and start to want to use that data in simulation, want to use that data also to perceive it in 3D. So GIS industry was used to do more 2D type, analysis. Now they are moving in the 3D space, start to use simulation, which start to actually have the M&S component of it combined with their analytic part. So those two industries, GIS and M&S industries, are converging as one now. So and then with all that put together, so we need to have a rapid way to work on the information. So what is velocity? Velocity is actually a workflow that take all those inputs. It's taking all the GIS input from raw data, from some of it pre-processed data, and then start to combine it as something meaningful, something standardized, and then some data or database, if you want, like OGCCDB in this case, which is the format that we'll be using to actually store that information with all the layers that we know today of CDB, but that will contain additional layers that, as we go, that will populate the database. The key point there is the workflow. And the workflow needs to be automated, because if we do it like we're used to do it like in the past, so manually take the data, have somebody start to process that information, look at it, fix it, and then save it, and then pass it on, and then start to combine the different geo information, that's too long. That takes too much time. So automation is the key word there for velocity. It's automation becomes critical to the workflow. We are in now today. There is as I was saying, there is so much data that is available on a daily basis. We cannot wait weeks or months to create a database. If we have data, it has to be almost near real-time processing, and then near real-time update of those databases. Otherwise, by the time, if we keep doing it in the old-fashioned way, by the time we have the information, that information is not good anymore, and then we have to start over again. So automation is key, and then to be able to do automation, that's where we have need to figure out how to automate, efficiently. So that's where artificial intelligence is key now in those processing. And then that will help to automate the whole process. Where ultimately, when we have the database
created, so it has to be simulation ready. So as you have seen from Nick, from Jay, and then from Philip, all the data now is meant for simulation, is meant for training, is meant for research. It's used for various function or for various needs. And then that's where the data needs to be what we call simulation ready. So it has to be all processed and then put in such a fashion that we could efficiently use any layer of information to take advantage of it, and then being able to do a concise simulation out of it, or do some research, or do round robin, not round robin, but Monte Carlo type simulation. And then that needs the whole process. Ultimately, the goal is to have that whole process in a near real time. So from freshly new taken satellite imagery, having in less than an hour or shorter if possible, that data being updated in the database, so I'm able to use it in the simulation. So as I was saying, artificial intelligence is key in this case in the automation. So at Presagis, we have started for a year now to do artificial intelligence research. So as an example, building footprint extraction from satellite imagery. So that's only the start. So that allows us through computer vision intelligence, artificial intelligence, being able to extract building footprints and then automate that portion, not to have a human draw lines around the buildings and then figure out the footprints, but let the computer figure it out for ourselves. And then building footprints, it's only the start. So there would be vegetation, identifying rooftop of buildings, clutter on top of buildings for, let's say, special ops type or mission specific information or geointelligence. And there would be road extraction and then many more other type of features we could extract from those satellite imagery, leveraging artificial intelligence. Why all that? So velocity is a growth vector for the companies. We try to go inside on the mission operation side. We are moving from the regular training, purely training. So for us, the growth vector are to start to actually widen the defense market with what we are already offering. As Jay explained already, some of the other vector of growth. But the geospatial expansion is a key one, where the GIS market is a huge market, where they have more and more a need for 3D and a need for modeling and simulation. And then with that, then naturally from the GIS, then the expansion could move to the twin cities, a digital twin, could move to a mobility aspect, could move to smart cities, and then that's where we start to allow us actually to have a growth path, not just in defense, but in Connex market, or let's say parallel market, and then which has a huge need in GIS simulation and 3D simulation. So we have JPER Smart City. So that's a program that we did last year with in collaboration with Dassault System in India, where the goal was to simulate in the city of Jaipur a green corridor for emergency vehicles. So in a nutshell, Velocity is about automating the creation of a dynamic virtual environment. That's the key foundation. And then that will allow us to grow into multiple new markets with a new business model. Typical synthetic environment where, at the bottom you have the terrain, you have the material information about the terrain, then you start to build up the environment, vegetation, infrastructure, the environmental, so where you start to have the dynamic aspect of it, like a weather server, ocean servers, and then those type of simulation. And you add a pattern of life, which are, for example, an urban crowd server or urban simulation. And then on top, you have the scenario or what you want to simulate. So those systems for us as a new business model is the goal to keep it very fast, very accessible to the end user, So the way to go forward is to provide those that velocity stack, if you want, as a data as a service for what touch the database and then what touch the geospatial information, but also simulation as a service as an offer to very quickly leveraging the cloud technology and go very quickly build up a scenario as the data, fresh data is coming in, being able to consume it, get it prepared, and then have it ready for simulation within hours. So you're able to very quickly being able to do your simulation or your research or to do some analysis on the fresh data that is coming in. On that, Joe, passing the microphone to you now.
All right, thanks very much, Eric, and thanks to all the panelists. I just want to spend a couple of minutes wrapping all of this up and giving everybody a context as to, what do we see when we look at all of these areas of technology and where we're spending time and attention focusing on new developments. And I think it's really interesting to reflect on, what's happened as technology has advanced, especially over the last 10 years. In fact, I can remember back in the mid to late 2000s, before 2010, we as a company had embarked on a number of different initiatives looking at artificial intelligence. We developed CDB as a concept, and all of these things, at the time, CDB certainly became a key element of our simulation and really drove requirements in the market to actually allow us to build a common format for synthetic environments. But it was only one piece of the puzzle. Artificial intelligence at the time was relatively fragmented. It wasn't easy to access, and it certainly wasn't easy to integrate into our simulation. But lots has changed, right? We look today, we have cloud technology, which allows us to store extremely large amounts of data, actually conduct processing and analysis in the cloud, which removes the requirement for us to build hardware to support any application that we want. We have the advent of serious gaming and gaming in general, which has certainly increased the fidelity and dropped the price of software that we can use and incorporate into our overall solutions. We see changes in terms of the recognition in the market, whether or not it's on the defense side, it's on the commercial side, it's on civil training applications, it's in healthcare, for the requirement to be able to take and interpret large amounts of data, with the whole concept being, I want a capability that actually uses data and provides me an answer about a question that I have, or about learning a system, or certainly incorporating into training. And what I think you'll see with the 4 panelist discussions is key pieces of that puzzle, right? We talk about training applications in the context of CAE tracks. We talk about the military application of common synthetic environments and how that can manage data at multiple levels of classification. We look at velocity as an ability to generate and auto-generate synthetic environment data, provide software as a service. We look at the broader applications of synthetic environments and see that not only are they applicable to military operations, but they're also applicable to any kind of analysis of things that are happening in the environment. And I encourage people to really start thinking open-mindedly about what would you do if you had access to data, access to analysis capabilities, and you had a question that forced you to say, I got to take a bunch of data, I got to do some processing on it, and I need to come up with a result that allows me to do better in my job, or allows me to better predict the future. And if you think about all of what we do, whether or not it's training, whether or not it's support to mission and operations, it's really about looking forward to the future. As a trainee, you want to become better in the future so that you can operate more effectively in a piece of equipment. If you're a military decision maker, you want to have a system that allows you to see the future again and improve your planning to ensure that you meet the mission requirements of whatever mission objective that you have in the military or in an operation. On the civil side, you can imagine, and by civil I mean at the governmental level, you can imagine planning for purposes of planning. I need to build out a city. I need to deploy infrastructure. I need to determine what the best routes are, for traffic, for signals, etc. All of this is converging, right? And I think you can see how as a company we have evolved from simply looking at a point-end application of training into something much broader, right? And taking the capabilities that we've developed up until now often in pieces. And as you can see, again, evidenced by the panelist discussions, we've all started to converge. So we have convergence internally on where we're going with our technology. We have convergence in the market with people recognizing the need for that technology. And when you link it back to Mark Perron's, set out strategy for us over the next 5 years to be a high technology company, you can all imagine that we're extremely well positioned to fulfill that strategic objective for us and certainly for the market, our current customers and future customers. Thank you for joining us for the discussion on technology trends at CAE with our technology leaders. If you're interested in further exciting discussions and information on CAE's digital technologies and innovations, a panel titled Leveraging Disruptive Capabilities Through Digital Immersion will take place at the upcoming CAE One World Conference and Trade Show, debuting in February 2021. I encourage you all to attend. Thanks very much.
Thank you for listening to CAE Defense and Security Podcast. If you want more information on CAE, please visit cae.com.